The atmosphere consists of oxygen and other gases like nitrogen and water vapor, hydrogen. But did you know that the air we breathe also consists of tiny little particles called aerosols? Aerosols are very important for lots of reasons. For example, aerosols are thought to be important in climate by changing the properties of clouds. If you didn't have an aerosol, it would be very difficult for a cloud droplet to form. In the air, water molecules attach themselves to aerosols, and as they condense, a cloud droplet is formed. The aerosols act as seeds to start the formation of the cloud droplets. In any location, the amount of aerosols in the atmosphere can change how far we can see, the frequency of clouds in the sky, the thickness of clouds, and even the rainfall amount. Some aerosols are naturally occurring in the atmosphere, like sea salt, pollen, and particles produced by volcanic eruptions. Other aerosols are human-made, like factory pollutants, automobile exhaust, and smoke from biomass burning.
Can aerosols affect the temperature here on Earth?
Sure they can. When aerosols like smoke and dust and pollen float in the air becomes hazy. Now, if this haziness reflects sunlight back to space, the effect is going to be a cooling of the atmosphere on Earth. But if this haziness absorbs energy, well, then the net effect is going to be a warming of the atmosphere here on Earth.
Studying the atmosphere is a fairly new science. In the Chemistry and Dynamics branch of NASA Langley Research Center, atmospheric scientists are trying to determine how many aerosols there are and where they are in the atmosphere. Now, these aerosols are important because they affect our health. Small aerosols can enter our lungs as we breathe polluted air. These aerosols can be deposited deep in our lungs, blocking the lungs' ability to exchange oxygen and carbon dioxide. Over time, this makes it hard to breathe. Here at NASA Langley, we measure aerosols using a technique called remote sensing.
What is remote sensing?
Remote sensing is collecting information about an object without physically touching the object. It's learning without touching. The most familiar kind of remote sensing is the use of our eyes to detect a distant object.
We also learn without touching when we hear. For example, when a car beeps its horn, we hear it from a distance and sense we're in danger.
Get out of the street!
You know, there are two types of remote sensing, active and passive.
An early example of passive remote sensing involved the use of a camera. In 1858, the first aerial photograph of land was taken from a balloon floating over Paris, France. This is called passive because the camera uses only the light from the sun to record the image on film. On the other hand, active remote sensing uses its own light source. Put a flash on the camera, and you've made it active because the light from the flash reflects off the distant object being photographed. Using active remote sensing, you can take pictures whenever you want because you don't have to depend on the sun to give you light.